Hello students, so this video is a 8.7 exponential and logarithmic equations using change of base. Alright, so first thing first, you guys do have your quiz, which should be 15 minutes. So if we could please, if you're watching this as a whole class, we're going to have the teacher in the room go ahead and distribute the quiz, and then please start a timer either on your phone or on the Apple TV and just put it for 15 minutes. So you'd pause this video. Go ahead, put a timer for 15 minutes. You don't need to project it. You can also just have it on your phone. And then I like to give about half and then last like 2-3 minutes as a warning. Okay. And then it'll be collected. Go ahead, pause the video so you can take your quiz. All right, thank you so much. So we're going to get started with our lesson here. We have properties of real exponents and properties of equations with exponents and logarithms. So for these two cases here, we have a whole bunch of different formulas that we've used. You should not need to memorize these formulas like, oh my gosh, I didn't memorize the formula. This should be like, hey, I have the formula for my use. But you should know how to use these properties on your own without saying, I'm going to use property 7 or property of equations 3. Right, so we should be able to just use these. So I think as we go through, you'll get the hang of it. First part, solve each equation. There are 4 total examples, 4 whiteboards, and partner activity. So there's quite a lot to do. So we got to pack it in. First thing we're going to do is, you notice they're both raised to the power 2. So because they're both already raised to the power 2, we can essentially just set our exponents equal to each other. Going to move everything over to one side. And now you're going to solve for x. So we're going to have to factor. You're going to get 7 and 1, minus and plus. So x equals 7, x equals -1. -1, comma 7. So there's my 2 answers. I got them. Okay, and make sure I got these. All right, cool. So we're going to continue on. All right, next side. You'll notice here we have an 8 and a 4. Okay, so I know some people right away are going to be like, just divide them, 8 and 4. You can't divide the 8 and 4, but you can rewrite them with common bases. So the 8 here, we can write with a common base of 2. And that would put it with a power of 3 times 4 minus 2x. And on the right, we'd have a base of 2. And this puts it as a power of 2 times x plus 2. Okay, now that I have common bases, my exponents can be set equal to each other now. So I have 3 times 4 minus 2x is equal to 2 times x plus 2. So I can distribute here 2x plus 4, 12 minus 6x. Make sure all my like terms are on one side versus the other. Alright, so I'm going to put 8x over there, move over the 6, move over the 4, should give me a 8. So x is really equal to 1. So I'm going to put x equals 1. And yes, you want to put your variable first. All right, there's the first 2 examples. If you need to pause so you can write them down or look at them one more time, go ahead, pause. Otherwise, we're going to practice on the whiteboard. So you're going to have a couple to practice with right now. So here we go, your whiteboard problems. You can do these on your iPad. You can do them on the large whiteboards in the room. It's your choice. So go ahead and start these problems. Go ahead, pause the video. All right, thanks so much. So we're going to check these answers. You should have -3, and you should have -1 and 3 over 2. So these should be your 2 answers. Go ahead, check them. Make sure you have everything as needed. for these problems. All right, we're going to keep going. Good job. So example 2, here we have it. It says solve each of the following exponential equations. Round decimals to the nearest 4 decimal places. So 4 places after the decimal dot. So we're going to have to do that. So here's what we're going to do. We're going to look at the first one. We're going to see, we have 10 to the power of 3x. So I bet if I were to put log in front of both of them, it's equal to log of the power 2.1, right? So what's happening is, because this is base 10 of 10, that cancels. So this was the property rule that we had, that becomes a 1, right? And it said whatever your exponent is becomes the answer. So this is log 2.1. You're going to divide by 3 on both sides. X is going to be equal to, let's see, log 21 divide 3 is 0. Oh, not 21. Silly me, it's 2.1. Oh my goodness. See, this is why you have to be careful. 0.107, and it said 4 numbers, so 4. There you go. All right, next up, middle problem. If you need to pause so you can keep writing, go ahead. Middle problem. So we're going to do the same log base. Notice this is 6 to the power x. So instead of log 10, if I put log base 6 of 6 to the 8x, look what's going to happen. Log base 6 of 18. Well, the 6's cancel. The x is going to be log base 6 of 18, which your calculator can type just like that. But if for whatever reason your calculator can't type that, we're going to do log base 18 over log base 6. So either way, that should get what your calculator is getting. So I'll show you in here. If you go to math and you go all the way down the bottom, there's log base. You're going to put 6 of 18. Okay. And the other way you can do it is just by putting log 18 divide log 6. There you have them. See how they're the exact same answer? So it's approximately 1.6131. I'm going to go back and just make sure my other one says approximate as well. Did I put... Oh, I forgot to approximate. Got to put approximate. We're rounding on these. Anytime you round, you have to put approximate. Okay, so that one worked out pretty nice for us. Look at that. You can also... So continuing on. This middle problem has another way of doing it. The other way of doing this problem would be to put log base 10. It will still work, of 6x is equal to log base 10 of 18, right? The x gets moved in front. X times log 10 of 6 equals log 10 of 18. You can divide both sides now by log 10 of 6, log 10 of 6, and you get x is still approximately 1.6131. It's that same fraction we have up here. It's the same. So this is the same as here. So either way, you will get the right answer. So you see, some of these have multiple ways to get the same answer. And that's okay. Multiple ways to get the same answer. There's nothing wrong with that. So for the last one, on this example, we're going to look at this problem and see how we have a 5 and a 10. We're going to put log of base 10 to both sides. So log base 10 of 5 to the 2x minus 1 is equal to log base 10 of 10 to the x. That side's going to cancel. We're going to get x equals log base 10 of 5 to the 2x minus 1. Okay, this whole exponent, remember our power rule said that exponent can move in front. So if it moves in front, log base 10 of 5 is equal to x. And because that exponent is in front now, what we really can do is we can take these problems and we can actually go through and distribute that 2x minus 1. This is where sometimes it gets confusing. But you're going to distribute this to each piece here. Switch colors for you. You're going to distribute here, and you're going to distribute into here. So you're going to end up with 2x log 5 minus log 5 is equal to x. And then you want all the x's on one side and everything else out of the way. So I'm going to switch my log 5 and the x. So we're going to go 2x minus x equals log 5. Oh, 2x log 5. Sorry, guys, I wrote the wrong thing right here. Oh, my goodness. Okay, there. Now, you got to factor out. See how there's an x on both of these? You got to factor out the x. 2 log 5 minus 1. Divide both sides. 2 log 5 minus 1. 2 log 5 minus 1. X is equal to approximately equal to. All right, let's do a fraction. Oh, no. Math. Oh, no. Alpha frac. Log 5 all over 2 log 5, close it, minus 1. So, approximately 1.756 5. 756 1.755. There we go. All right. So, there we have it. Ta-da! Okay. Once again, there's another way to do this problem as well. There's multiple ways to do each of these problems. So, I got my answer. All 3 answers. Ready to go. If you need to pause, go ahead, pause. Otherwise, we're going to keep moving forward. And my answer here, 756. Oops, this needs to say 5. I put a 3. That's a 5. Everything else looks good. Okay, so, whiteboard problem. Go ahead, pause the video, get started on these whiteboards. Thank you so much. Hey, thank you so much for coming back. Here we go. All right, your answers are as follows. There we go. Sorry. Your answers are as follows. These are the options that I found to be able to solve these. There are other ways you can do this. Like, for example, if you put log base 4 to both sides, your answer would be different, right? So you can do those if you want. You can also leave everything in base 10, which is what some students prefer to do. So solve equations, common bases, different bases. That's your choice. Either way, this one on the left got a little complicated if you did it the same way I did. If you did a different way, well, then it was okay. All right, example 3, moving on. Here we go. So, first thing you're going to have to do, use the properties of logarithms to solve the following equations. You need to condense them first. So, see how they're all log of something? X over x minus 1 is equal to log 3. Okay, so that part's nice. Now, what's going to happen is because they're both log, and they're both base 10 actually, It makes it really nice because remember how we could put just like a 10 on both sides and it cancels out the log? So this was really just x over x minus 1 is equal to 3. So you can multiply both sides here by x minus 1. So you get x equals 3x minus 3. You're going to solve for x, remember? So you're going to move all the x's over. So 2x is equal to 3. 2, so x is equal to 3 over 2. We did it. There you go. We have it. There's your answer. Yay. That one wasn't too bad. All right, the one on the right is going to be similar to begin with. You're going to have to write out that fraction first, except it's a natural log. ln of something over something here. So x squared minus x minus 6 over x plus 2 is equal to 2. So this is really the natural log of, what do we have here? This is going to be x plus 2 times something over x plus 2. And I'm betting that x plus 2 is going to be a common factor there. So just taking a guess here. It's going to be an x, what do we say, minus 3? Yep, minus 3. Okay, so the 2's are going to cancel. So this is just really ln x minus 3 is equal to 2. Okay, well that's awesome because remember when I said put everything to the e? That's how you write an exponential. So x minus 3 is really equal to e squared. Okay, so x is really equal to e squared plus 3. Look at how quick this is on my calculator. E squared and plus 3. Ta-da! So x is approximately equal to 10.3891. There we have it. Sorry, it took a second for the extra 1 at the end. Go ahead, pause it if you need to pause it, so you can catch up with the whiteboard. We're going to keep going otherwise, so you can practice some of these. So remember, a lot of these have similar ways to get there. There's many different ways to solve these. You just need to use the properties. You don't need to state which property, but you do need to do and use the properties. So, so continue just with these same properties. So here we go. We're going to do our whiteboard. Use the properties of logs to solve the following equations. Here we go. All right. Properties of logarithms to solve the following equations. So, go ahead, pause, and start on your whiteboard. All right. Thanks so much for coming back. Here we go. We have 2 answers. Sorry. One of them does not work on the right side. You initially have 2 answers, 6 and -1, but you can't have x equals -1 because it would lead to an undefined. Right? We can't take log of a negative number. We talked about it. It's a non-real answer, so we can't do that. So that would be undefined. So unfortunately, that one would not work out so well for us. And we're going to keep moving to the next example. Please excuse my coughs in here. I am trying my best for you guys, but I am still sick. So please excuse my coughs. Okay. Vocab. Here's the change of base formula we have. There's your change of base formula. You're going to go ahead and continue with that formula. So remember, this is the same one I showed you in the calculator when I said if you have a log 5 of 22, right? That's some of your calculators. Only do log 22 over log 5. So this is change of base. So you will need this formula. And it's not a formula like, oh, I should memorize it. It's more like this is a procedure that we need to follow. So, ta-da. All right, last example, and then we have partner activity. Yay! Use the change of base formula to evaluate and solve. So the one on the left, all they're really asking you to do is show the change of base. 3.42 over log 2. And in your calculator, when you do that, you would still get the same answer. Log 3.42 divide log 2 is 1.773. Oh, no, that's 40, because we have to round. So you're rounding for that one. All right. Sorry, it doesn't say, you're going to round to the same place, so 4 decimals. 7, 7, and then 40, yeah. All right, the one on the right, in order to do this, we're going to put log, we're going to do change of base. So you're going to do log base, log base 5 of 5 to the x is equal to log base 5 of 16. And remember, those essentially cancel because the x, what's really happening, to be honest, is we're using power rule. So x goes in front. X times log base 5 of 5 is equal to log base 5 of 16. So those of you before who were like, how come every time the exponent, it just goes, everything else just goes away? It's not that it's going away, it's because the exponent's in front. And this really cancels to be a 1. So it's 1 times x. So it's just x. You don't need to put 1 times x, right? This we can do in the calculator. Your calculator actually can handle it as it is. You can also write it in the change of base format, which is to put the logs on top like this. Change of base, right? So if I were to do log now of 16, oh, that did not push log. Log 16, sorry, divide by log 5. And if I were to do math, scroll all the way to the bottom, log base 5 of 16. I should get the same number. There it is. So x is approximately 1.7227. So this is the same answer. Notice your calculators, most of them have the change of base formula. And so you don't need to do change of base because your calculator is already there. But it's an important skill in case, should you ever perhaps find yourself in a situation where you need to do a different, use a different calculator perhaps, like a scientific one. Okay, so that's change of base. We did it. Yay, we made it through, people. We made it through. All right, partner activity is left. And then it's homework time. So we're almost at the end. So you have 2 partner activities to do. The first one says solve each of the following. You can use any of the methods you learned today. You could put log base of each. You can do common roots and just put 4 to the power of something, right? I think that would work. You can do log base, whatever you want. Go ahead, pause these. This, I'm going to say, would be about 5 minutes. If you need longer, that's okay, but we'll give you about 5 minutes and then check in for that. If you finish sooner, that's wonderful. So just go ahead, pause the video. You're going to work for about 5 minutes and then come back for the answers. Okay. Thank you so much for coming back. Okay, here are your answers. Last time we did a partner activity and you had a video, I gave you some of the wrong answers accidentally. So I am very sorry. And I am hoping that these are the correct answers this time. I'm not, I feel that they are the right answers. But then again, everyone makes mistakes, including teachers sometimes. So please check. If you think there's an answer that's wrong, please email me. Don't just go with it. Please email me so I see, and you can screenshot and I'll check my work, okay? Thank you so much. In the meantime, we're going to move on to the next partner activity. Here's the next partner activity. You're going to work with your partner. Go ahead. We're going to give you, it's 2 problems. This one, it's going to be a little bit more. So maybe we're going to do like 4 minutes. I think it's a little faster. All right, go ahead and pause and work with your partner for about 4 minutes. Thank you. All right, thanks for coming back. Here's your answers for this problem. These are your answers. Once again, if you think I have a mistake somewhere, please tell me. Please email me. Don't just suffer in silence. All right, and that's it for all I have for you here. At this point, with the time that's left, you are welcome to work on your assignment. There are plenty of practice problems, by the way. You are welcome to work on your assignment. Please go ahead, start on your assignment. I hope you guys have a great rest of your day. Yeah, I will talk to you later. Goodbye.